I say Pythagoras or Pythagorean, what do you think of? What? Okay. See, you know, this is one of the most common things. If you ask an adult, like, do you remember anything from math class? You know, from high school or whatever, they might be able to tell you that they remember the quadratic formula, but they will probably get it wrong. You know, negative b plus or minus square root, all that stuff. They have a better chance of getting the Pythagorean theorem right, of remembering that. So a squared plus b squared equals c squared. Our Pythagorean identities in trig look a lot like that because they come from the Pythagorean theorem. It's like x squared plus y squared equals z squared. But in trig, around the unit circle, what's x and what's y? Okay, around the unit circle, what's x and what's y? Okay, x is cos squared theta, and y was sine squared theta. So what in the world will that turn out to equal? All right, if you go around the unit circle, what would cos squared plus sine squared work out to be? Well, let's see if we can figure that out. Let's think about the unit circle. You thought you were done, but all right, what's right there? I just drew it.
1, 0.
That is 1, 0. Okay, what does the 1 represent? Cosine. All right, and the 0 is sine. So use the formula. In this case, what would cosine squared plus sine squared turn out to be? 1, right? 1 squared plus 0 squared. Okay, how about this one up here? That is 0, 1. What does cosine squared plus sine squared work out to be there? Still 1. Okay, and then over here on this one, this is negative 1, 0. What will cosine squared plus sine squared work out to be there?
1.
Also 1. And all of the positions around the unit circle work out to be 1. Does it only work on those edge corners? Nope. What would you say that one is right there?
2, 2.
Not 2, 2, but rad 2, rad 2. And you know what? If you do cosine squared plus sine squared, it still works out to be 1. Doesn't matter what you pick. All right, so it is equal to 1. This is called the Pythagorean identity, and you have to memorize that value. You need to know that cosine squared plus sine squared equals 1 all the time. It will never change. That will always be true. All right, now, using the following three numbers, somebody make me a math statement that is true.
2 plus 3 equals 5.
Okay, 2 plus 3 equals 5. Can somebody make me another math statement that's true using the same three numbers? Okay, 3 plus 2 is also 5. That's the commutative property of math.
Negative
Sam?
plus negative.
Okay, you can't use negative numbers, but you have to use 2 and 5 and 3. 5 minus 3 is 2. Okay, that's using subtraction. All right, anything else? 5 minus 2 is 3. Does it work to do 3 minus 5? No. Okay, that won't work because commutative property doesn't apply to subtraction. All right, so why were we doing basic math? I'm showing you that you can take any three things and rearrange them and still have a true math statement. It could be either addition or subtraction. So, using cos squared and sine squared and 1, rearrange it and make me something that is still true. Okay, just like you used 2, 3, and 5, and you wrote me like 4 different things that were all true using 2, 3s, and 5s, what else could you tell me about using those 3 things? It sure does. Okay, sine squared theta plus cos squared theta, in that order, would still equal 1. Give me some others.
1 minus sine equals cos.
Okay, 1 minus sine squared theta equals cos squared theta. It does not work without the squares. If you drop the squares, it's not a true statement anymore. All right, and what's the final one that we haven't done? 1 minus cos squared equals sine squared. All right, so these 4 you need to memorize, or at least memorize the first one and then be able to switch them around and know what the other ones are. These are called the main big Pythagorean identities in various orders as long as they have the squares. then it's a true statement. Okay, there's a couple others that you'll need to be aware of, and it all comes back to the beginning. So start over. Cos squared theta plus sine squared theta is 1. So I can say rearrange that with addition, you could have something new. I could say rearrange with subtraction, and you'd have something new. Now I'm going to tell you to rearrange with division. All right, I'd like you to divide by one of those things. So either by, well, what happens if you divide by 1? Nothing. Okay, so that's pointless. So then let's divide by one of the other two things. Pick one.
Sine.
All right, she wants to divide by sine. So go ahead and divide each term by sine squared. And you're going to come up with a new statement that is still true. Okay, for the first part, what is cosine squared divided by sine squared? That is cotangent. Plus, what is sine squared divided by itself? 1. And then on the far side, what is 1 over sine squared? Well, if you know what what's 1 over sine without a square? And so then with a square, it's still cosecant squared. And that is also a true statement. And that statement can be rearranged with addition or subtraction. Okay, rearrange it with addition. 1 plus cotangent. Bless you.
Thank you.
Equals cosecant still. Rearrange it with subtraction for me. Use a subtraction and come up with something different. Cosecant squared, and which one are you going to subtract? Minus the 1, and then what would that have to be equal to? That would have to be equal to cotangent squared. And what's the last one that we haven't that you could write? What if you started with cosecant squared and subtracted the other one? What if you subtracted cotangent? Then what would you have? Then you'd have 1. There's 4 more. But they're all related to the first one. The first one was cosine squared plus sine squared is 1. You can rearrange that with addition. You can rearrange it with subtraction. You can rearrange it with division. So here's 4 more. All right, so last set. It's okay. Slides, let me go back one more. Okay, cotangent squared theta plus 1 is replaceable, it's the first one there, with cosecant squared. Why don't I just use the cosecant stuff that's on this slide here? Why 2 slides ago? Okay, yes, this is a theta, my problem's an x, that's not a problem, those are variables, but it's cosecant squared of the variable minus 1. Let's go back to the original. What's the original?
Sine plus cos equals 1.
Oh, yeah, we did cosine. That's okay. It could be it either. Okay, cosine squared plus sine squared equals 1. And our last one is going to be by division again. So there are 3 terms. The 1, the sine squared, and the cosine. Dividing by 1 does not create anything new. Dividing by sine, we just did. So now let's divide by cosine squared. So divide each part by cosine squared. And we're going to get our last set of new things that are true. Okay, and we are going to have cosine squared divided by cosine squared, which is 1, plus, what about sine squared divided by cosine squared? Tan. And then 1 divided by cosine squared is secant squared. And that is also true, and you can rearrange that with addition or subtraction. Tan is squared. The squareds don't reduce. Okay, and so you can rearrange that with addition and have tan squared theta plus 1 equals secant squared. Or you can rearrange that with subtraction and have secant squared theta minus 1 equals tan. Or the last combination of subtraction is secant squared minus tan squared equals 1, and that's the last set. So there are 12 forms of the Pythagorean identity, 4 from the first page, 4 from the second page, 4 from the third, but they all are related to the first one. You don't have to memorize all 12. You just have to memorize the first one and then know how to rearrange with addition, subtraction, or division to get the other ones. when you do your homework, you probably are going to want all 12 like next to you or on your iPad while you're working on your page so that you can do the changing in. Okay, Sam, you had a question.
My question was going to be if we're going to have to remember all.
Okay, so you'll have to develop them if you haven't memorized them. Okay, you have to memorize the first one, and then the rest you should be able to develop. All right, here's how it's going to go. It's going to look like, where do you see secant squared theta minus 1, and what would it be replaceable with? Tangent, not just tan, but tangent squared. Look back. I don't have any cotangent on that page back. Tan squared theta plus 1, that's right here. And that's replaceable. Slide. Nope, 2 slides. Is that not from a couple slides? Secant squared of the variable minus 1 is replaceable with tangent. All right? If secant squared, when I subtract, look at this last one. If secant squared here and tangent squared are in order of subtraction, that would equal 1. Okay, if that was the order. So let's take it from last night where it says simplify. So I'm not going to write the word simplify every time. I'll just write it for the first. Okay, simplify. All right, example number 1. Secant squared theta, and theta could be any variable. If you don't like theta, write x. It's not going to hurt my feelings. It's totally fine. Okay, minus 1 over secant squared theta. Please do not think that the secant thetas reduce each other and the answer is negative 1. Because I know that you're thinking that, or at least a couple of you are thinking that. Subtraction doesn't reduce. What's the only kind of math that reduces? Okay, this is not multiplication. This is subtraction. And so subtraction does not reduce. What I want to do is, because I see a secant squared theta minus 1, that is replaceable. Keep in mind, secant squared theta minus 1. Just remember what that was. I'm going to go back a slide. All right, so we're going to show equal to, and you can work, if you like to work across your page instead of down your page, that's okay. So we'll replace it with tan squared. And we haven't replaced anything with secant squared yet. So that was our first replacement. I would advise you to your next replacement to be your big division bar. Make that bar into the dot division signs. That would be my next advice to you, is to have that be equal, and then do tan squared theta division sign secant squared theta. Then you can do the replacements we learned yesterday. So this homework is going to be almost exactly like yesterday's homework, except the first step is going to be a Pythagorean. After that, it's going to be the same as what you were doing before. And so now we want to do a replacement for tan squared. Tan squared is sine squared over cos squared. So all of the identities you learned yesterday work with the squareds on them. Either way, they work with cubes, they work with 4s. Divided by 1 over cos squared, and that's the other replacement. I'm still in division, which means I can't reduce until I've made this a multiplication problem. So I want to make it multiplication. So I'll change it to times. And then I flip it to cos squared over 1. And once I'm in multiplication, I'm finally to the place where I can reduce. And I can reduce each of the cosine squareds with each other, and I will be left only with sine squared over 1. So your homework is going to be identical from step 2 on. Step 1 is always going to be find the Pythagorean. So let's try another one, and I want you to look for the Pythagorean that you're going to use as your first step. All right, here's the question. Cotangent squared theta plus 1 and tangent squared theta plus 1. So now you've got 2 to look for. So you want to find what cotangent squared theta plus 1 was equal to. So I might have to go back a couple slides. So I can go ahead, and this one is replaceable with cosecant squared. And then the bottom one is on just secant. So now we've got secant squared. That's always going to be your first step, looking for Pythagorean. Now you just want to follow the rest of the steps. Erase that. Okay, so I'm going to advise you to use the division bar now, is to change that into cosecant squared theta, and then change it to divided by secant squared theta. Okay, don't make it be a division anymore, make it be division with the division symbol. And then replace each of those with their 1/overs. So we've got 1 over sine squared divided by 1 over cos squared. The last thing to do would be to change division to multiplication. And so multiplication becomes cosine squared on the top over 1. And now that I'm finally in multiplication, I can reduce. Whoops. And the 1s are reducing, but nothing else, leaving me with cos squared on the top and sine squared on the bottom. Who knows what that is? Good, Rose. All right, and that is cotangent when you have cosine on top, and that is the most simple that it could be. Rose. Yeah, take the pass, please. Okay, stop me if you have any questions. Any questions on the first two? Okay, example 3. Parentheses, cosecant x plus 1, parentheses, cosecant x minus 1, and the instructions are still to simplify. All right, what's our first step? Nicely done. All right, Jalen says distribute, which is a fancy way of saying FOIL. Okay, why would I not just look back one work in this question? There's no squareds. Okay, there are no squareds, and if you don't have squareds, it's not Pythagorean. All right, so we're going to do FOIL instead. Okay, first, outside, inside, last. So when we FOIL, cosecant x gets FOILed to another cosecant x, which becomes cosecant squared x. The squared always goes between the trig part and the x. It doesn't go after the x. That's the way we write it in trig. And then minus 1, so we'll have minus 1 cosecant x. That's the O. The I is plus 1 cosecant x, and the L part is minus 1. What do you notice when we get cosecant squared x minus 1 cosecant x plus 1 cosecant x minus 1? What happens? Okay, so the middle two, the terms that came from O and I cancel out, and I'm left with cosecant squared x minus 1. Now I have one of my, so cosecant squared of the variable minus 1, what does that ultimately equal? Cotangent squared x. Very good. That's as simple as it can go. I can't simplify that anymore. Okay, number 4. Till the bell rings, babe. Okay. All right. Cotangent x, secant squared x minus cotangent x. Oh my goodness. We just have brilliance in this room all over the place. Okay?
Don't gas him up. Don't gas
All right.
No.
Yes. Okay, this one is an operator. Okay, Brandon, what kind of factoring? What's that called? Greatest common factor, all right? So this is an opportunity to do GCF.
I said you're smart.
All right, so what we see in common is that we have cotangent to pull out. When we separate the cotangent out from the problem, I have secant squared x minus, and then what's left? Because there still has to be something, minus 1. After I've done that, it's kind of like playing I Spy. You should see I Spy the Pythagorean. Okay? And again, if you don't remember the Pythagorean, it's okay. We'll just peek back. So we'll go ahead and we'll replace it with tangent squared. Not just with regular tangent, but with tangent. Both of those are replaceable as well. Okay, what is cotangent? Back to day one. What is just regular cotangent replaceable with? Cosine over sine. And then what about the tangent squared that was next to it? Sine squared over cosine squared. And a square means how many of them are there? There's two of them. And so you might find it helpful to write both of them down. We've got sine x and another sine x next to it over cos x with another cos x next to it. You don't have to write that if you don't want to, but if you like to see it all kind of spread out like that, you can. And because this is multiplication, I can reduce. So my upper cosine reduces with one of the lower cosines, and my lower sine reduces with one of the upper sines, leaving me with just sine over cosine by itself, which is tangent. Okay. Nope. 5.
25 minutes, you said? Sheesh. I gotta get out of here in 5 minutes.
Okay. All right, let's try another one. Secant squared x plus cotangent squared x minus parentheses tan squared x plus cosecant squared x. Is this FOIL? Why not? Okay, what would there have to be FOIL? 2 sets of parentheses to be FOIL. This one doesn't. So what do I do with that one parentheses and with what's in front of it? I just distribute the negative. All right, great. So I just distribute the negative. All right, so secant squared theta plus cotangent squared theta minus tangent squared theta minus cosecant squared theta. So I just distribute the negative. All right, now I need a 1 or something to make this Pythagorean, because all the Pythagoreans we've worked with have had something to do with a 1. So let me peek back and look here a minute. Can I do anything to make that order happen here? Is it legal for me to change spaces with those two things? Oh, sad.
Thank you, Ms. Fife.
You are welcome, Jelani.
Hey, it's rainy.
It is really raining. What's that, Thomas? Coming up
I
now.
thought that was Thomas' conversation. I was like, Thomas. Come back. That'd be fun. What do you mean?
Mary. Say no, Mark. So, no, just give me that. Just trying to get new grades or something from here. I always like jamming in between. You do? You.
No, I don't.
I follow you.
I do not do that.
Did you turn in these? I have a sticky note on here. Did you turn it on canvas or what?
Trevor.
I was interested.
Already got it. Yeah. There's a last year's video's already there. So where do you want? Take advantage of the snow. Okay,
Should I email you homework or just turn it on?
Monday is fine. Just bring it with you on Monday. Yeah, last year's video is already there. So, and I'll do a new one tomorrow and post it for afternoon.
Nice.
Okay, bye.
Oh, Miss Pfeiffer.
Yes.
Hi. I'm going to, I committed to Long Beach.
State?
No, yeah.
Cal State Long Beach?
Yeah.
feel good to have that?
Like, yeah.
Are you gonna live at home or on campus?
I was planning on living at home. I'm really poor, so.
At some point, you should live on campus just to have that experience.
Yeah, I was planning on only going there for 2 years and then transferring.
Okay.
So hopefully I can stay there. So.
Alright. So who else? Let's see, we've got Garrett and you and Kat. That's all I know of so far. Do you know of anybody else from your class